My expertise is in telecom. I worked on wireless and brought wireless phones to India. So, electrical engineering, there is supposed to be electronics and communication engineering which deals with telecom and wireless, and there is supposed to be electrical power engineering which deals with power. The two are within electrical engineering quite distinct, often do not even talk. So, my expertise is not at all in the area of power, conventional expertise. But what was happening is about 4 to 5 years back at Chennai, whole of Tamil Nadu, we are facing very heavy power cuts. Even in city of Chennai, their average day power cut was 4 hours. In places like Coimbatore, power cuts was 12 hours. And it was hot summer, and without power, we were suffering like anything. And at that time, I used to often talk to my colleague who worked with me in wireless area, Dr. Bhaskar Ramurthy, that I wish somebody had done work in power the way we did work in wireless. India desperately needs something, and something has to be done. And after days of talking, going nowhere, one day the two of us sort of said, why don't we work in this area? Our first reaction was, we don't know anything about it. This is 4 years back. But say, so what? If at this stage we cannot learn, then what good are we? So, we jumped into it. We started looking at solar. We said solar may be a way out. And there was a colleague of ours who was doing some work. So, we will learn and we will start doing things. And what I am going to present to you is something that I believe that we have been able to make a significant mark, and title therefore I have put as Green Homes for India. What can be done for India? Our experiences in India, and I am talking about all homes in India. We will talk about most homes in India. And at the same time, if you look at my byline, enabling India to get 50% of its power from solar by 2030. That is a kind of dream and vision with which we are working. And we believe that it is not just an empty dream, because we are fairly confident that we will help India achieve something like this. Now, that is what I am going to talk about, and in this context I start with a very simple fact. First of all, I do not know whether many of you know that about 50 million homes are still not connected to the grid. The numbers have been going down very rapidly, there has been a huge push to connect them, but still fairly substantial number may have gone down. But there are about another 100 million homes throughout the country, out of 250 total million homes. Another 100 million homes get load shedding between 2 hours to up to 12 hours, particularly during summer. And cities like Delhi may not get much load shedding, cities like Bombay may not get much load shedding, but otherwise load shedding is theirs. Though let me point out, over last 3 to 4 years, there has been very rapid increase in power generation. There used to be a gap between what is called supply and demand. That gap has been narrowing. The peak hour gap was very bad, even the peak hour gap has been narrowing. But somehow still this situation exists, particularly you walk down to UP, even a few tens of kilometers away, and you will still see heavy power cuts, especially during summer. So, that is the reason why the third point becomes very important. 50% of Indian homes cannot afford power, and if you do the economics, they cannot afford power at a subsidized rate of 5 rupees per unit. 5 rupees per unit is 1 kilowatt hour. At that rate, 50% of homes cannot afford power. In fact, even within daily elections, this became an issue. 5 rupees per an hour per kilowatt unit is too high. And though at 5 rupees per unit, DISCOM, the power distribution company, lose money. So, there is everyone tries to sort of do some cross subsidy and even push it below 5 rupees. And DISCOM is losing money, is not interested. So, somewhere does not do enough to keep the power on. This is the kind of situation overall, and therefore, when we started working on power, very quickly learned about all this, that we need to solve a much larger problem, not just a problem of availability, but affordability, access, all these problems have to be solved. And we started working, and we did something, and I will talk about it. We installed something, but I will start my talk by a story, something that happened in December of last year. Most of you know that last December, Tamil Nadu and especially Chennai had a very, very bad floods. I do not know whether you understand the degree of damage that was caused. Think about 10,000 homes, their first floor was completely, ground floor was completely submerged with water. The water had come to the first floor. Your DBT secretary, his mother, ground floor was completely submerged. First floor she had to move. But pretty much 4 days there was no power in the city. Even at IIT-Madras there was no power for 75 hours. There was power, some diesel generators were there, so they were on for first day. By end of first day, most of the diesel ran out and diesel was not available in the city. We have 1 megawatt solar power plant on the rooftop at IIT. That plant shut down, because that plant works only when the grid power is available. So, pretty much there was completely dark, but it is in the middle of this, there was one home, my home, which had lights, fans, cell phone charging, laptop charging, even a television on. It was on. And what I had was a solar panel, but my solar panel was only 125 watt solar panel, which is what, size of about 4 times this table, 0.7 square meter, less than 1 square meter, not even 1 meter by 1 meter, very small panel on the rooftop. And I had a half a kilowatt hour of battery. So, I had a little backup, which I knew I had, but I did not think it is going to last long. So, I was very worried that yes, I have power. First, of course, initially I thought the power will go off for a few hours, it will come back. But as we started hearing the news that the city is getting submerged and the power stations are also filled with water, we realized that we are in for a serious trouble. And then I was all the time worried that I will lose the power. So, I was using it very carefully. Typically 2 lights were on, 2 tube lights, 1 tube light all the time, 1 tube light less often sometime. I will dim the tube light. I had 1 fan on running at low speed because it was not very hot. Occasionally I will turn television, I had a large television, but shut it off. What was most important was the laptop was charging and discharging, cell phone was charging and discharging. I was alone at home and there is nothing that you could do. So, I actually did in those 4 days more work than I probably do in 15 days otherwise, just sitting and working on laptop all the time. And somehow I managed connectivity, that is another story. So, when I was working, my laptop will discharge and then I will charge again and then I will again work or simultaneously charge and work. So, must have got discharged and discharged some 15 times. All the time I was worried that this power, that backup that I have will go away. Fortunately, it lasted. Immediately I could not add up. I had done enough work on power that how much watt hour I consumed, how much watt hour was generated, stored, and it took some time that we have probably done something which is much more than we had even anticipated. We had done a major thing, what we call solar DC, a DC wiring, a DC power line at home. I had removed my AC power line, all the homes have AC power line, and I had put DC power line, and I had put solar, battery and connected all the DC appliances. I was connected to the grid was converted from AC to DC. And somewhere in that process we had done something, we had knew that it is going to give in huge efficiency. We had done all the background work, but not to the extent that actually it started performing. Now, I remember when we first started talking about DC power line, I talked with some of my colleagues that I am going to replace this AC power line by DC power line. And immediately somebody reminded me that this is a settled 125 years back. You are going back in history. And there was actually, there was enough on the website that there was a big debate of AC versus DC power line. What should one be used? And there was this Tesla who was strongly for AC power line, and Thomas Edison, the person who made the bulb, was for DC. And there was a big battle, lasted for several years. It was a bitter battle. It was a battle between two corporates, each lobbying with the government by even fixing the experiments. In fact, showing that one is more dangerous than the other, and really fixing it up. You should go and read the report, you will see how corporate and science often work together, but that is what was happening. And finally, after such bitter battle, the AC won decisively. AC won decisively because AC power could be transferred from the exchange, from the power station to tens of kilometers. Now, when you transmit it tens of kilometers the power, there are losses on the line. But if you increase the voltage substantially, the amount of current reduces, and the power is losses are proportional to the square of the current. So, if you can increase the voltage by, let us say, 10 times, your power will go down by 10 times, your losses will go down by 100 times. How do you increase the voltage and transmit, and at each home bring down the voltage? Now, this was not doable in DC very easily. In AC, a transformer was developed. Transformer actually was developed in somewhere in Europe, I do not remember exactly, Czechoslovakia or some place, and that technology was obtained by Tesla and said, well, we can do this, and therefore, from a single generating station we can power all these homes and offices, and AC won. In fact, Edison more or less shut down his complete stuff, and after that converted to DC, converted to AC, and primarily it was reducing the losses. So, since then AC has dominated. Till that time AC and DC both were there. Transmission all over the world became completely AC. There were traces of DC, did not last for long. Homes and offices were all wired on AC line. In India we wire it at 230 volts AC, other places it may wire at 110 volt AC. All appliances are run on AC, your bulb runs on AC, everything runs on AC appliances, and all R&D was on AC. So, all this protection and every other device was also done on AC, all switching. There used to be R&D on DC before that, virtually nobody funded it, gradually started fading away, nobody is using it, disappeared. And it is this background that we professors, this time we are fortunately not that young, when we started talking about wireless we were young, and people sort of say maybe they have gone senile, they are talking about DC power line. We had done our homework, we sort of say future is DC, and we are not so worried about being called senile, because I remember back in 90s when we were introducing wireless instead of wired line, that time people were also sort of saying, well, these people are crazy, they do not know what it means. You can never get wireless as good as wired line, and it will never be as inexpensive as that. And we said, well, that is the future, it is a wireless phone which is going to be much cheaper and much better, and fortunately we succeeded in that. So, in some sense the fact that people were calling us senile did not worry us too much, except even our young colleagues used to often look at us, walk by our room and sort of said, well, time has come for them to retire. We know the time is coming for us to retire, but we were not ready to at that time. What was the reason why we were looking at DC? Look at this, A solar panel, rooftop panel, there are 125 watt solar panel that I had on my rooftop, that you put it in the sun and it produces power, except it produces DC power. It does not produce AC power, that is the nature of a solar panel cell. So, this it produces DC power, we have to convert this DC to AC. Now, if the panel was large, a 10 kilowatt panel, 125 watt is 0.7 meter, 110 kilowatt would have been huge panel, probably bigger than this room size. If you are using something like that, it is not as bad. You can probably convert it with some minimal losses. But if you do 125 watt and you do a DC to AC conversion, there is a minimum of 15% loss. There is a minimum of 15% loss. And if you have a battery stores only, gets charged by only a DC power. So, you have to again convert the AC back into DC. And when you take the power out from the battery, again there is a DC converted to AC. So, once again there is a DC to AC converter. There are 3 converters involved. You synchronize it to the grid. Of course, if grid power goes, only 2 converters are involved. If grid goes directly to the load, no converter is involved. But if solar goes directly to the load, sure, only 1 converter is involved. But very often solar has to go through the battery, because solar power is fluctuating, it is not constant. So, there are 3 converters and the minimum losses in each converters were 15%, in fact higher. One could design it for 10%, but then the cost will go very high. Compared to solar panel, the cost of this converters will become very high. So, you are seeing a loss of about 45% plus the losses in the battery, that is on top of it, that is about 10%. So, what we actually found is that conventional system, the ones that were installed by my colleague and he was doing research and publishing paper, 55% power had gone away. What kind of economics will work? Solar panel was supposed to be expensive, battery was expensive, and most of the power that you are putting in is you are wasting. And it got actually worse. We next started looking at what do you do with this power? Well, we first use it for lights. That is the first thing that we tried to do. The lights were so far being used was the CFL light tube, that was all right, but we knew that the future is LED. Now, LED lights are again only DC powered, they are not AC powered. If you use AC, you have to do a AC to DC conversion. So, one more converter, and with CFL tube will take about 36 watts, whereas LED tube will take around 15 watts, and you could dim the LED tube. CFL you cannot, you could dim it to 3 watts. In fact, this is what I had installed at my home. So, very often I was consuming only 3 watts. If I was not eating and I was not reading something, even if I was working on my laptop had light, I did not need very bright light, 3 to 6 watts, I did not need that much of light. And I realized that this is DC powered rather than AC powered. The second thing was fan. The fan, of course, I had studied when I was a student, undergraduate, it is AC induction motor fan, and it was 72 watts, and even if you run it at the lowest speed, it still consumes close to 60 watts. But while discussing, one of my colleague came and sort of say, you can actually make a brushless DC motor fan, which can be consume much less power. So, we sort of said, well, why not build one, and we helped build that, and we found that consumes only 30 watts, but that is a DC powered, that is not AC powered, brushless DC motor, it is DC powered. So, if you use AC, you have to do one more AC to DC conversion, that was the problem. And when it run at a very low speed, it will consume only 9 watts at the lowest speed. Now, immediately the question that I started asking, why has AC fan proliferated, why has DC fan not come up? Of course, one reason was that we had only AC power coming in at home, but the second reason was that for you driving this brushless DC motor, you needed a permanent magnet, plus you needed a power electronic circuitry. And this power electronic circuitry used to be very expensive, but with the power electronics integrated circuits coming around 2005 or 2007 onwards, the cost of power electronics integrated circuits were falling like anything, and today one can design a brushless DC motor fan and manufacture it at a volume of about 1,000,000 numbers, which is not very large, at pretty much the same price. So, if I had direct DC power, it would have helped me. If I have AC power, even if I use this, I will need another loss, 15% loss. Then what is the next most important thing that you use? Well, you use television, you use laptops, cell phone, electronics, but here we knew all electronics uses only DC power, they do not use AC power. So, this laptop is using AC power and it uses an adapter, AC to DC adapter. I measured the AC to DC adapter losses for my expensive HP laptop, the losses was 34%. I had a Nokia cell phone with a very expensive cell phone with adapter, I measured the losses, 50% losses. I had a Sony television, I opened it up and measured the losses in AC to DC conversion, there was about 23% losses. So, everywhere there are losses in AC to DC conversion. If I had a DC line, possibly I could have avoided that. What was I seeing? Home appliances are gradually moving to DC. And once I could do motor, in fact, motors will go into refrigerator, into washing machine, into mixer, into air conditioner, all of them DC made more sense. And I started talking to people and people sort of say, well, all these things will become DC based, it is a matter of time. Then why am I using AC power at home? Well, because in this 125 years back, in this debate between Tesla and Edison, Edison lost, Tesla won. So, I will waste most of my power by doing AC to DC conversion and use these DC appliances, made no sense. If I could use DC appliances, I could save 50% power, and if I did not have to do that AC to DC conversion, I will save significant amount of power. It is at this point we sort of said, take a break and do a complete DC system. Of course, questions were asked, are we ready to take a DC power line at home, at offices, at commercial complexes, industry? Let transmission remain AC for a time being. We at the entry of these homes will convert that AC into DC. But then appliances will be DC, power line will be DC, solar will be DC, batteries will be DC. Why not have completely DC? And of course, question came, you will have to need to standardize voltage, just like 230 volt was there, we have to standardize voltage. And we debated, almost a year it took us amongst different people, different faculty members, engineers, faculty members of different IITs, and it was felt that 48 volt DC will be ideal. The reason 48 volt DC will be ideal is because it is a safe voltage, you can touch that and you do not die, that is the most important thing. It is used by telephone line, in fact, a wired line telephone uses that 48 volt, it is used on power on Ethernet. So, there was enough experience. It could easily drive LED, electronics, that motor, 48 volt DC would be ideal. One also thought, why not? So, one had to be safe, safe means below 60 volts. So, 48 was fine, but somebody sort of say, why not 24 volt and 12 volt? Well, a simple calculation shows that if I bring it down to 24 volt, my losses, line losses will go up by 4 times, and if I brought it down to 12 volt, my line losses will go up by 16 times. Made no sense when I am powering the homes, and actually the current wiring that I have, I can actually use it for 48 volt quite easily. I can't use it for 12 volt and 24 volt. Of course, so therefore, we sort of say we will work with 48 volt. We realize that if you want a really high power like air conditioner etc., that 48 volt will be too high a power. If I want a kilowatt hour of power, my current will become 200 amperes, which will become unsafe and not good. Maybe I need to do something else at that time, and that time one could sort of say, well, for higher power wherever more than 10-20 amperes will be used, one could use something like 380 volt DC or higher voltage DC. So, that is what one could do. And so, we sort of said we will make the complete solar system completely DC, powering a DC line. We call what is called solar DC, solar DC. So, solar panel will give you DC power output, grid will give you AC which will be converted to DC, battery will be charged using DC, battery will be giving output as DC, the load will be all 48 volt. So, lights, fans, electronics, everything will be powered by 48 volt, television, everything will be powered by 48 volt. It is of course very highly efficient. The grid alone is converted. From the grid I am drawing certain power, but the local power, expensive power like solar and battery I do not convert, and it is designed to have minimal losses. Of course, the problem was very fairly soon realized that something like this is easy to draw, not easy to design, because while I sort of say solar panel should give 48 volt, yeah, it will nominally give you 48 volt, but throughout the day depending on the sunlight available, the voltage will keep on changing from 44, 45 volt to 51, 52 volt. So, it will not give me constant voltage. My battery, what voltage will it charge? Depends on the state of charge. It could go down to 45, go down to go up to 55, 56. So, I have to vary this voltage while this is independently varying, and my load has to be fixed. So, design became non-trivial, and one still had to deal with different voltages, and this voltage could be independent. How do you combine, make all those voltages same? The first reaction was put a DC to DC converter, but if you are going to put a DC to DC converter instead of AC to DC converter, you may slightly have better losses, but more or less the same kind of losses, and our objective was to remove those losses. So, therefore, design became complex, but then complex design is something that you have good students who are willing to work very hard, sooner or later they will solve that problem. So, we were able to design the whole thing to have a minimal losses, total losses being not more than 7-8% instead of 45%, and one can do even better as you go further. So, this once we are able to do this, the problem was we are talking about a DC power line, that means everything had to be done afresh, everything had to be designed afresh and commercialized. Until it is commercialized, until it starts selling at volumes, the prices will be very high, and if the prices are very high, nobody is going to use it. And that is where the work from technology development, science and technology development understanding went up to promoting entrepreneurship, commercialization and things like that. So, we started designing this inverterless. Why are we calling it inverterless? Well, all of you are probably familiar with the equipment called inverter. Most Indian homes have an inverter. Whenever power fails, that inverter comes in. We are doing pretty much the same to begin with. We are doing much more than that, but we are doing the same thing, but we are not inverting. We do not have that DC to AC conversion, we have directly. So, we call it inverterless, and we designed it to have a solar panel, expandable solar panel, all the way from 150 to 25 watt to 250, 375, 500 watt solar panel, depending on the requirement. We could connect to the grid, 230 volts, it will convert AC to DC. We could connect it to the battery, and we in fact redesigned the battery to be a high performance battery, but again a scalable battery all the way down to 1 kilowatt hour to maybe 5 kilowatt hour, and give a DC output, up to 500 watts, and it could power homes. But since we are designing in 2015 or 14, we actually also added a Bluetooth for monitoring. So, my cell phone can actually talk to you. That I will tell you the reason later on. That is a very important decision that we took. In 2014 anyway, this will have a powerful processor. For designing a Bluetooth is not such a big deal, my cell phone can then communicate. But this was not the only thing. We had to not only design these things, commercialize it, we had to design a bulb, 48 volt DC bulb. There was no bulb available, LED bulb. Well, we designed, got it, commercialized it, and remember, we have to get volumes. We had to design sockets, and sockets has to be different. If you can see, the socket has one connection like this, another connection like this. I do not know whether you can see that properly. The reason is, unlike the AC, where you can put the plug like this or like this, it does not matter. In AC, it does not matter. DC, it matters. There is a plus and minus. You cannot put it inverted. So, we have to put one like this and one like this, such that you try to put it the other way around, it does not go in. It has to be made safe. And therefore, we have to design each plug, even getting plastic box, the connectors, everything had to be designed. We have to get the fan designed and commercialized, 30 watt fan, 9 watt at the lowest strip. We had to design tube light, and since again we are designing in 2015, we could actually design it with a remote, such that the fan can be turned on and off and reduce speed, and light can be turned on and off, and speed can be controlled, and all this including inverterless, fan, light, sockets, bulbs, solar panel of 125 watt, battery of a kilowatt hour. What was used to begin with at my home would cost around 20,000 rupees, including remote and all that. And you can add more solar panel, add more battery, and add more appliances as you want. Well, one went on to design more. For example, in cities like Delhi, you are used to a desert cooler. A typical desert cooler consumes about 180 watts. We designed one with 80 watts. Primarily changed the regular induction motor to brushless DC motor, DC powered, 48 volt DC. Televisions, well, television internally worked. All that we had to do is get the manufacturer to bring the power line out. So, in the beginning they said no, they won't do it, but when we said what if we buy 100 numbers, they said then they can do it. We asked them what if we buy 10,000 numbers, so then they will give us a discount, because then they will remove the AC to DC converter, and they told me that 92 or 93% of their failures of a television actually takes place in that AC to DC converter. So, you are going to make it more reliable, rugged. So, we are able to get them to do it. We designed a mixer, and this is another very interesting thing that we did. A typical mixer consumes 350 watts peak, we designed it to consume no more than 150 watts. Everywhere more than 50% saving, and directly powered by solar and battery and DC, remember that. Here we did not use brushless DC motor, we designed another motor called switched reluctance motor, SR motor. In fact, when we started working on it, first we got to know about brushless DC motor, and then I heard some people talking, some of my colleagues talking about this switched reluctance motor, SR motor. I said, what is this? So, that is another DC motor, but that is far more complex, do not touch it, it is more difficult to design. We did not, our first fans and other things were designed all with, and this cooler was designed with brushless DC motor. But you know, one of the things that when we were designing brushless DC motor, we were sort of recognized that we are dependent on a permanent magnet, and the source of that permanent magnet, the material for that permanent magnet primarily comes from China. And as demand for those permanent magnet, either niobium based or ferrite was going up, they would push up the cost. And we sort of said, well, we will never be able to get the most optimal cost for this. So, once I was talking to my colleagues and sort of said, well, we have to find a way out. Is that the only way? Is there India, does it have this mines? So, we have some mines, but we have not been mining it. What else can be done? And at that time, one of the sort of said, well, I am working on SR motor, it will take me 5 years to develop it. I said, what does SR motor have? It is a much more complex power electronics, but does not require a permanent magnet. So, what does it require? It requires steel. See, is the steel produced in India? Yes, SAIL produces one grade of steel which can directly be used. What else does it require? Coils, which is produced in India. Then the electronic circuitry, which we can design. Of course, the ICs will come from outside. We say, let us accelerate this work. And we put a bunch of very bright youngsters, a large bunch, and we are able to start designing the SR motors. And today we have commercialized it. We have put it in this mixer. Now we are making a Bellona, the one which churner, milk churner. We are making a atta chakki. In fact, the requirement for this atta chakki and Bellona came later on. I will talk to you when we started deploying in villages of Rajasthan. They said, we want those things if you really want this to happen. And we started designing. And everything has to be designed and commercialized. And we have to generate sufficient quantity of orders to begin with to get the price at the right market point. 3 years of tough work, bunch of 200 people, youngsters, average age probably 25, 26, very bright ones, work 16 hours a day. We go around shouting, but they are the one who work, and they come up with solutions, one after another, very innovative solutions, and we actually designed this whole thing. And once we designed these things, we needed to could deploy. Fortunately, after initial thing that the senile people, somebody believed in us and say, okay, go to this Rajasthan deserts. We have not been able to take grid there. There are 4,000 homes there, not connected. Some of them are in border of India, Pakistan. Can you connect them? We said, why not? In Jodhpur and Jaisalmer district. And we started connecting them. Tough terrain, no vehicle can go there. Some of the places only camels can go there. Fortunately, some of the places a tractor can go there, no other vehicle. You can't even walk properly because of sand. But we are able to go there. We did that, we finished that work, we will talk more about it. And now we are getting more. Next thing we sort of said, hills of Assam. We never will be able to take a grid there. It's a very difficult terrain. Can you go there? So, why not? Can you go to Orissa, Jharkhand? Well, if once you have done Rajasthan and Assam, the other things become easier. But remember that we have not designed it for only off-grid homes. We will talk more about it later on. So, in these deserts of Rajasthan, we started deploying. If any one of you want to go and visit there, most welcome. We will tell you where to go, but we started going and deploying them. Many of the places, people told us their first time they have seen power. And we went to huts where there were no hooks, and we had to create hooks to put fans. We had to get the local technician, train them to mount the solar panel. This is the size of a solar panel, gives you some idea. We had to create lights, we had to do all kinds of things, but of course, has to do something which is reliable and is going to last. These 4,000 homes gave us excellent field conditions. Remember, the system design was new and complex, and each subsystem was just about optimized to be the lowest cost and lowest size, with the aim that we are going to reduce losses. When we reduce losses, see, instead of 50% losses, we are down to 6-7%. That means our size of solar panel and battery will go down. And since it's a DC appliances, we consume less. Because we consume less, size further goes down, which means cost comes down. We are doing something which couldn't have been done even at 3.5 to 4 times the cost if it was an AC system. But then we had to do optimal, we couldn't overdo it. And when we were doing this, of course, the immediate question came, are these all going to be really realized in practice? In labs they were working, in my home it was working, in my office we in fact powered one of the students' hostel, women's hostel, one of the wing wired. We saw there it was working, but will it work everywhere in different remote conditions, in field? We didn't have a clear idea. We believed it will work. Will all subsystem work? Why will they not fail after 1 month? Will the battery remain healthy? Have we not made mistakes? And believe it or not, we had made more mistakes than we could have ever imagined. But normally you will go deploy, clap, get photographs and forget about it. But fortunately there is one thing that we did. We say we are going to, we will monitor the system all the time. It is not enough to do, particularly early, but later on I will say we will not only monitor, but also manage. For diagnostic, performance evaluation, manage them. We will measure the solar power coming in every day, every few minutes, power going into the battery, power coming out of the battery, power being used in the grid and by you using the load, and if the grid is there, the power being supplied from the grid. Building such diagnostics electronics was not that difficult, because there was a processor, all that we had to do was appropriate sensors and some software. But how do you take it to the cloud, and so that we can get it? Require connectivity to the cloud, and it has to be low cost, because cost was our paramount thing. And when we designed the initially thing, well, our cost of that box was around 3,000 rupees, 3,500 rupees. And when we started trying to add a modem, it was adding another 2,000 to 2,500 rupees. Made no sense. Then there would have been a monthly cost for uploading. It is here we thought of, and that though I told you about earlier, that why not put a Bluetooth? Because even in Rajasthan when we went there, while the people did not have electricity, in a village of 80 homes, there were 20 mobile phones. Where would they power it? Well, they would power it when they go to town, and connectivity was there. So what if we use Bluetooth and get this to talk to the Bluetooth, and whenever there is a connectivity, it will upload to the cloud. There is data connectivity on these phones, that was not a problem. So we started doing this, and we got very interesting result. The first thing that we got, first day I got such nice result, beautiful solar. This kind of solar you can only see it in Rajasthan, flat, morning to evening, does not change much. Battery keeps on charging, load is being used, and there are other days it was a little more fluctuating. The question that we started asking is the power, the losses, is customer using more than what the solar power produces, is the customer using less, is the power being wasted, what can one do, is in a grid connected system are we optimizing, and are there faults? And as I pointed out, which I am not going to tell in detail, there are lots of mistakes that we have made. Some silly mistakes which we did not detect in our first few hundred systems at IIT-Madras and a few places that we had deployed. We saw it only when we went to Rajasthan. There is certain kind of shot that can be done, repeated shot can be done. We had tested it for some shot, but if repeated shots are done, our system blows away. So we had to go back to the drawing board, figure out what went wrong, because we are monitoring, and find the solution and find the answers. At the same time, we had developed a mobile app, so that on the customer phone, user can track how much energy they are using, how much battery is there. If there is no power, how long will the power last? Have a fairly good estimate of that. These are straightforward stuff, because when we are doing that, and for grid connected systems, help user avoid waste. If I am running out of power, can I do something? For example, one very interesting thing that came out in Rajasthan, everything that we did, in spite of that, sometimes somebody will overuse it, and solar every day is going to produce only so much power. If they start overusing it, sooner or later they will run out of power. When they run out of power, the whole place becomes dark, and people did not like it. Of course, one could say that expand the system, but that will remain more cost. And then we sort of said, well, what can be done, and then we came up with this whole idea of emergency line, a normal line and emergency line. We says, well, battery goes below a certain level, we will cut off the main line and we will allow only emergency line, which can only have 2 bulbs to be used. So, your lights are at least 2 lights are on, and that can last for next 24-36 hours. So, those feedback are very important. Somebody says a user centric design, actually user giving us feedback, but of course, the other feedback that they gave is that they wanted atta chakki, which was not so easy to design, took us almost a year. Today we are designing that. Of course, villagers are thrilled. Many of them sort of said that I am now able to give my students homework. We did it in schools, for example, happy that in the summer they can study. There are people show around the solar system, and there is lots and lots of feedback that is available on the website. One can actually look at the details of that. The main reason for going inverterless, solar inverterless, solar DC, it actually gave us multiple things. First of all, it gave us solar, a decentralized solar, a solar that I can put on my rooftop. I do not have to transmit power. Remember, if I do not transmit power, I am not even going to have these transmission and distribution losses. And I know solar is the most green form of power. So, first it gave me a solar, second it gave me a backup, which in India in particularly one needed, because power fails quite often. We use inverters, so it gave me a backup. Number third, being far more efficient, it was going to give me something which is far more cost effective. These were the 3 things. And then of course, one sort of said, well, 100 watt DC or 125 watt power, this is the kind of panel that I used. Is that, what can that do? Well, we very quickly calculated it was a fully DC system, 3 lights, 2 fans and a cell phone charging, or 3 lights, 1 fan, 1 television, small television of 24-inch plus a cell phone charging. Just look at this. Our lowest income homes are quite happy with this to begin with. 3 lights, maybe a tube light and 2 bulbs, one in the kitchen, one in the bathroom or in the porch, a fan. Most of these homes are single room homes, single hut, a television, today they want that, and a cell phone charging. 100 watt is enough for doing this. So, when we are going to these Rajasthan homes, we were going to give them this, and this is lights no different from your lights at your home, like your tube lights at homes or bulbs at your homes, not some inexpensive, some lower quality and lower luminance. A fan, a normal fan that you and I use in our homes. A television, slightly smaller, 24-inch, but a normal television, and a cell phone charging. One point that I want to make, that one thing that had impressed me during the campaign that took place for national election in 2014 was that just because somebody is poor does not mean that have to live a deprived life forever. That statement had come several times, and one realized that when one going to off grid homes does not have to treat them, oh, we will give them some torch or some small bulb or some low light or little toy fan. Give them the same thing that you and I like to use. Of course, make it more efficient, and this is what 100 watt light can produce. Of course, solar panels and batteries have to be appropriately sized, devices can be added as required. So, you can start with this in the minimum, and at 500 watts you can have 4-5 fans, 10-12 lights, a large television plus a small television, 2-3 laptop chargers charging, 3-4 cell phone charging, a small refrigerator or large refrigerator, a regular size refrigerator, which covers almost all the things that we use. Of course, it does not cover air conditioner, maybe even a mixer one can use. This mixer is not all the time used. Will not cover air conditioner, will not cover your sole water heater, will not cover microwave oven, but one needs even that, one can go for another 500 watts. What is the big deal? But my home, for example, does not even use 500 watts. I have my home converted now to DC. Now, just to understand the cost, and this is very important. So, we did these computations and then verified it with the actual field thing. We took a home, not the poorest home, a home which is low income, 2 tube lights, 2 fans, 2 bulbs, 1 phone and 1 TV. And I put number of hours that they will be operated in a day. One can change any of those things, one has to just redo the computation. And then we started sort of saying, what does it take cost per day of operation of all this, electricity cost per day. When we calculate the electricity cost, and if you use it with solar panel and battery, we have to understand that we have to calculate the total cost. For the solar panels and the battery and for the inverterless, we have to put their depreciation, calculate the lifetime of there, and based on the lifetime appropriate it that this is the cost per year or per day. Calculate the interest rate, very important to calculate interest rate, and interest rate in India is high, 13-14%. Very often we forget that. You need to calculate that if you really want to understand the true cost. And unbelievable what it came. If I had no load shedding, let us say, and if I ran this kind of home, my power bill will be 16 rupee 30 paise per day, 500 rupees per month. And 500 rupees per month, very low income homes in Delhi will find it difficult to pay. And that is where the agitation etc. starts. What if I had DC home? It will cost me only 6 rupee 45 paise per day, about 200 rupees. Why? Simply because I am using DC appliances, consuming half the power or roughly half the power, we avoid wastage. What if there was a 4-hour load shedding and I had appropriate battery and solar? My cost will go to approximately 29 rupees per day, closer to 900 rupees per month. My DC system does not change too much, it does go up to 20 rupees per month, still very affordable. And of course, if you are totally off grid like in Rajasthan, my cost here will go up to 50 rupees if I had AC system, 1600 rupees. Here it is high, but we are talking about 360 rupees. So, if you see the advantage increases as you go with their power cuts. But even if there is no power cut, you are saving about 2.5 times, 2.4 times. Off grid home with solar DC here completely off grid becomes lower than your on grid cost. This is the obvious way to go about doing it. If you put solar with AC system, what is happening? These systems have been designed in somewhere in Europe or United States, brought in out here. Nobody has thought through this and goes and puts this. There is such a large government program, there is such large schemes, largely subsidy driven push, and people just get away with it. Nobody is bothered to really design things for India, and that is where we sort of say, and we have to do it differently. When you design for India, and I am talking about any emerging market, this pretty much will be very similar, though there may be differences in place to place, one has to rethink the whole thing, and the numbers suddenly starts looking very different. And remember, here I have taken my interest cost to be 12% or 13%. What if my interest cost is less? I will gain much more. That is where the advantage is. So, the other point is, it is equally important for grid connected homes. My home, for example, huge benefit it took place, even if there was no power cuts. First of all, what does it do? It gives me, it is a DC power line, DC appliances give me high cost savings. Even if there is no power cut, it gives me high cost saving, and it draws less from the grid, reduces power bill. There will be some power cuts, and it provides backup for power. Free homes if there is a grid fault or if there is a power cut, and on top of it is very green, and I am going to emphasize that green part more. So, all three things are there. Then one said that, one told me, Jhunjhunwala, what are you talking about 500 watt panel? So, what does it really matter for the country? Country needs gigawatt. Somebody came from United States and said that you are taking. I said, let us do a simple calculation, 500 watt, we have 240 million homes, put 500 watt in every home, calculate the total sun hours available, total power. We calculated the total power produced will be 190,000 gigawatt hour. How much power did we consume in 2015 in India, all the domestic sector? This is 180,000 gigawatt hour. So, the 500 watt can actually produce equal to all the homes, all the domestic consumption. We do not need any more for domestic. So, it is not small. Why are you talking it is a small? We have the numbers. And then he of course immediately sort of says, well, but you know today people use so little, what if they use more? I said, well, they can make it 1 kilowatt, or who says they cannot use it more? And one is not saying that one can still draw from the grid, and India can become the most green nation. That is a point that I want to make. Well, the other point that I want to make is DC power line plays an equally important role in commercial complexes, high rise building, hospital, institutions, educational institute. Take this place. What time do you work? Morning to evening. Sun is there morning to evening. You do not work in the night much, occasional use. You design this properly, design it DC, decentralized, you will make a huge savings. Not just for powered appliances, but for even air conditioning, cooling, lifts and pumps. In fact, you know, one of the most interesting thing is, when do you require the most air conditioning? When it is the hottest. When is the hottest? When the sun is the brightest. When is the sun bright? When sun is the brightest, what will happen? You will produce maximum solar power. There is a natural demand and supply match if you use solar. Question is, are we willing to do that? Are we going to do it in conventional manner, or are we going to sort of really take a little bit of our own design and do it? It will require changes. It will not happen immediately, because lots of things may still be missing. Somebody may come and say, oh, this is not DC. Well, we can have AC and DC line both. Use AC line wherever DC is not there. Enough things are there. In one institute with a bunch of startups, if it has been able to produce about most of the things that we need in the country for homes, why can't we get together and produce these things in the country? And as I told you, SR motor can be done. We do not even need brushless DC motor. In fact, there is a lot of opposition. People say, oh, you are going to import things from China. And this is what we have started doing. For example, take apartment block, offices, hospitals, commercial complexes, educational institutes, all of them, you take solar, you take grid, combine, put a DC. What are the things that you use? Use laptops, so DC powered. Desktop PCs, use DC powered. Routers, use DC power. Display screens, use DC power. Variable airflow volume and VFD for air conditioning, use DC power. Exhaust fan can be DC. Sensors, every sensor is a DC sensor. In fact, in one room I went to, office room, we found there were 100 AC to DC converter, because every sensor, every time you wash your hand and it senses and water starts flowing, there is a sensor, but the sensor is electronic sensor has to be DC, and there is a AC to DC converter. Mobile cell phone charging, lights, LED bulbs, everything is DC. We can start saving between 30–40% straight away if we start moving in that direction. So, efficient use of smart buildings, rooftop solar powered, natural supply and demand match for cooling. Use DC power line to power its lights, fans, electronic loads and sensors. Air conditioning distribution systems, you can be designed again DC powered, but air conditioning, we have done it. These are things that are, all the results that I am showing you are the results of things that we have done. We have IIT-Madara Research Park where we are building it. Best driven by DC motors, brushless DC motor, SR motor, because after all, even lifts and chillers are motors. The primary consumption, all of them, if you use DC motor or what is called variable frequency drive, which is again DC powered, they all start helping you like anything. Water pumps, lifts would benefit from DC power with VFDs. Should be able to pump most of the water during daytime when sun is there. In for our agriculture sector, it is possible if you do it properly. Of course, just blindly bringing things from outside will not work. One of the things that even if this idea comes, somebody will say, okay, let us bring this thing, somebody where has developed. They would not have developed it for Indian conditions. We must be able to repair things, manage things in each place. If you are going to rural areas, we should be able to handle it there. We can't just import it. Well, to sum up, green DC powered homes driven by solar DC, it can provide power at affordable rates even during load shedding. Lower middle class homes cannot afford power at even the subsidized rates today. All the homes will draw less from grid, reduces losses for DISCOM. It is a very important national objective to move towards this. Similarly, DC powered buildings with rooftop can reduce power consumption, again require power. Remember that what is the power sources that we have? We have coal, our hydro is more or less exhausted, whatever we can use. So, we can either grow in coal or we can grow in solar and wind. Coal we can grow, but only problem is coal is polluting. Solar, if you want to grow, you have to make things more efficient, and that is a direction that you really need to go. India must aim to make 50% power produced by solar, using solar by 2030, and a significant percentage of it will come from decentralized solar and rooftop solar, not centralized solar. Focus in India has been only centralized, where everything is imported. There is a push, but decentralized solar can change all this. I will say, which is of course another talk, you can invite me, I can possibly give that, but not today, that India has to aim that by 2030 100% of its vehicles become electric vehicles and will use the electricity, solar powered and other electricity. In fact, it can help a lot, because vehicles can be charged in the night time when otherwise the grid demand is the minimal, it will help our power sector. But that is another talk. Today I will end that India can become and will become most sustainable and green nation if we decide to. Same time we solve the problem for our lowest income people, same time we can help by developing all these things and manufacturing it in India. So, if you ask me, this is the Make in India program, it is linked to all of this, and It just requires you to think differently and be determined. There will be odds, things will not work, but one can get things done. Use young power of youngsters. Many of the things that I talked about has actually been done by startups, where 25-year-old, 28-year-old, 30-year-old kids virtually lead these things. They need a little bit of guidance and can push the horizon. I think that is all that I want to talk today. Thank you very much.